Okay, page 2, problem 5, we have this set up, the integral from 1 to e of this quantity x squared minus 1 all over x. All right, this looks like a u substitution problem, but it actually isn't, okay? Because we make u equal to x squared minus 1, well then du would be 2x. We don't have 2x dx. I left off my differential. Shame, shame. But that's not what we have. What we have is really a 1 over x, because remember, this x is in the denominator. Dx. We can't quickly make a 2x into a 1 over x. So we can't use u substitution here. Which means we have to go to plan B. What's plan B? Well, we have to simplify this. We have a monomial in our denominator, so we can break up the fraction. And we all know that x squared divided by x is really just x. So this expression right here, x squared minus 1 over x, is the same thing as x minus 1 over x. Now we take our antiderivative. The antiderivative of x is x squared over 2. The antiderivative of 1 over x we know is the natural log of the absolute value of x. This whole thing is being evaluated from 1 to e. Makes a little more sense now why e is one of our bounds, right? Because we know e and natural log are going to work together. Okay, so what's happening? We plug e first. So we have e squared over 2 minus the natural log of e. And then we're going to subtract. Now we do the lower bound. 1 squared over 2 minus the natural log of 1. The natural log of e, we know that's just 1. The natural log of 1 is just 0. So e squared over 2 minus 1 minus 1/2. If you're subtracting 1 and you're subtracting 1/2, you're subtracting 2 halves and subtracting 1/2, so that means you are subtracting 3 halves. Oops. There we go. E squared over 2 minus 3 over 2. D is our answer. Number 6. Little f is a continuous function, and big F prime is little f. See, they do this on the test sometimes. It gets a little confusing with big F and little f. All right. What this is basically saying, obviously, is that little f is the derivative of big F, or another way of saying big F is the antiderivative of little f. All right. Let me write that down up here. Big F is going to be the antiderivative of little f. Okay. That might help us out a little bit here because we're asked to find the integral from 1 to 3 of little f of 2x dx. Right? Well, this is just f of x dx up here, but we have f of 2x, so we have u substitution going on here. Right? U is equal to 2x, which means du is 2 dx. Well, we've got the dx, but we don't have the 2. So we're going to have to put that in and the corresponding 1/2 out front. So what's going on here? 1/2 antiderivative. Now we have f of u du. As we did in the other page, we got to change our bounds. Right? We got to plug in 1 and we got to plug in 3. So our new bounds are 2 and 6. All right, so what happens here? We're going to solve this definite integral, which means the first thing we do is take the antiderivative of little f. Up here, the antiderivative of little f is big F. So we got big F of u. My goodness, I can't believe I'm writing that on the page. All right, and that's being evaluated. Oops, I left my 1/2 out front. I got to put that back in. And I've got 2 and 6. So 1/2 f big F of 6 minus 1/2 big F of 2 when we finish up the fundamental theorem. And that's D. All right, one more here on this page, number 7, more u substitution. All right, because we have e to the negative 4x, so it looks like u is going to be that exponent, that inner function. Du is negative 4 dx. We have the dx, we don't have the negative 4. So we need the corresponding negative 1/4 out front. So we've got negative 1/4 times the integral. Going to hold off on the bounds for a second. E to the u du. All right, because the dx and the negative 4 are out and du is in. All right, what are the new bounds? Well, I need u of 0 and I need u of 1. U of 0 is still 0. Negative 4 times 0 is 0. U of 1 is going to be negative 4 times 1, or negative 4. So what happens here? The low bound is still 0, but the new upper bound is negative 4. And yeah, your spidey sense is tingling here, saying, wait a minute, this is backwards. We need this to be the other way. Which means we have to negate the integral. But the integral is already negative. So now it's positive. And the integrand stays the same. Okay, antiderivative of e to the u is e to the u. But we still have the 1/4 out front. This is being evaluated from negative 4 to 0. 0 is the upper bound, it's the b, so we plug it in first. So we have 1/4 e to the 0 minus 1/4 e to the negative 4. E to the 0 is 1, so we end up having 1/4 minus 1/4 e to the negative 4, and that's C.